we're going to talk about arithmetic sequences, what they are, and how to find a formula and the terms. So we're going to learn how to determine if something is an arithmetic, we're going to find the next terms, and we're going to write a formula. So what's some important vocabulary? The first is the sequence was just a set of numbers. We have an arithmetic sequence. This is a sequence found by adding the same thing each time. And the common difference is what you added each time. So something like 5, 10, 15, 20, and so on and so forth would be arithmetic because we're adding each time. Okay, something like 2, 4, 8, 16 would not because we're doubling. So here are some examples. We have 3, 9, 15, 21, and 27. So our common difference, and we tend to call that D, is a positive 6. So that is arithmetic. 32, 28, 24, and 20 is also arithmetic, and we say that our common difference is negative 4. So each time we're subtracting 4. Okay, take a minute and see if you can determine if these are arithmetic or not, and if they are, figure out what the common difference is. Go ahead, I'll wait. Okay, the first one, we're subtracting 2 each time, or adding a negative 2. So that is arithmetic. And our common difference is negative 2. And the next one, we're adding 11 each time. So yes, this is arithmetic as well, and our common difference is 11. The last sequence, if we look at, we add 0, then we add 1, then we add 1, but then we go 2, 3, and then 7. Okay, so this is not arithmetic. And actually, it's a special sequence called the Fibonacci sequence. Now we have a specific formula for arithmetic sequences. That formula is a sub n equals a sub 1 plus n minus 1 equals d. So n is the number of terms we have. Okay. A sub 1 represents the first term. Remember, there's no magical mathematics to the n and to the 1. The little ones, they're just there to tell you which ones they are. D is our common difference. And a sub n is what we call the nth term. So if you were finding the 10th term, you would put the 10th term in there. Might look kind of confusing, but let's look at some examples. It says write an equation for the nth term of each sequence and find the 5th. It actually probably should say 50th term. But so if I look at this sequence from negative 3 to negative 8, I'm subtracting 5, subtracting 5 again, subtracting 5 again. So our formula is a sub n equals a sub 1 plus n minus 1 times the common difference. So we don't know what term we're talking about, so we're going to leave the a sub n alone. Our first term is negative 3, so it's going to go in here. Plus, we're going to leave the n minus 1 alone for now. And our common difference is negative 5. So there is the formula for finding the nth term. Now, it can be simplified if you chose to, but this is what we're really looking for. So the 5th term I can just follow the pattern. I've got 1, 2, 3, 4 terms. If I subtract 5 again, I'm going to get negative 23. Okay, but let's use this to find the 50th term. So if I wanted to find a sub 50, because we could find a couple, it just would get really tedious and boring if we tried to keep adding 50. So what I'm going to do is I'm going to say a sub 50, so it's telling me which term I'm finding, and I'm going to plug it into my formula. Negative 3 plus 50 minus 1 times negative 5. So negative 3 plus 49 times negative 5. And if I simplify that, 49 times negative 5 is negative 245. And then if I add those together, I'm going to get negative 248. So my 50th term is negative 248. I can find the 100th term using that formula. I can find the 1000th term using that formula. So the formula is a nice thing to have. So let's do another one. Okay. A sub n equals a sub 1 plus n minus 1 times the common difference. So what is my common difference? Sometimes the easiest way to do it is to take the first two numbers. I've got negative 10 minus 13 minus 3, and that gives me negative 13. So let's see if we're right. 3 minus 13 gives us negative 10. Negative 10 minus 13 gives us negative 23, and then minus 13 again gives us negative 36. So our common difference is negative 13. So a sub n is going to equal the first term, which is 3, plus n minus 1 times negative 13. So here's our equation or our formula. We've taken care of writing an equation for the nth term. And again, I'm going to change this to 50th term. Okay, so now when I sub in to find a sub 50, I'm going to go 3 plus 50 minus 1 times negative 13, or 3 plus 49 times negative 13. 49 times negative 13 is negative 637, so 3 plus negative 637 gives us negative 634 as our 50th term. So these are the two parts to the question we're looking for. There's the formula, and there is the 50th term. All right, we're given a formula now. It says find the 100th term of the sequence modeled by the following equation. So all I'm going to do is plug in 100 equals 15 plus 100 minus 1 times 7. So it's 15 plus 49, or 49, 99 times 7. So 99 times 7 is 693. So 15 plus 693. And when we add those together, we get 708 is our 100th term. Okay, we could also generate the first 5. We know what the first term is 15. And we know that the common difference is 7. So if I just keep adding, 7 and 15 is 22, 29, 36, blah, 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 just by adding 5 each time. All right, so we looked at arithmetic sequences today. Remember, they are sequences found by adding the same thing each time. Okay. The general formula for that is any term, or the nth term, is equal to the first term plus the whatever term it is minus 1 times the common difference. Have a mathtastic day.